In this video, I will be synthesizing iodine from potassium iodide, 5% vinegar, and 3% hydrogen peroxide. Both the vinegar and hydrogen peroxide can be obtained at a grocery store or local pharmacy. The potassium iodide crystals were purchased off Amazon. In this reaction, 2 moles of potassium iodide react with 1 mole of hydrogen peroxide and 1 mole of acid to form 1 mole of iodine, 2 moles of water, and 2 moles of potassium salt. This reaction is performed in a well-ventilated area or outside, as iodine generates fumes that can be harmful. To start, 200 milliliters of 5% vinegar was added to a 1000 milliliter beaker along with the stir bar. 25 grams of potassium iodide was then measured out and added to the beaker. The potassium iodide was allowed to dissolve. After the potassium iodide completely dissolved, a total of 400 milliliters of 3% hydrogen peroxide was slowly added to the beaker over the course of several minutes. This is my hypothesis for the mechanism of this reaction. First, hydrogen peroxide splits into 2 hydroxyl radicals. Then, in a redox equilibrium reaction, these 2 hydroxyl radicals oxidize 2 of the iodide ions from the iodide salt. When this redox occurs, it forms 2 iodide radicals and 2 hydroxide ions, which quickly react with the acid present to form water. This removal of hydroxide drives the redox reaction forward. Finally, the iodide radicals can form elemental iodine. After a few minutes, significant iodine precipitate has appeared at the bottom of the beaker and no more iodine precipitate seems to be forming. A vacuum filtration with a Buchner funnel was set up and the mixture was filtered through to collect the iodine precipitate. The precipitate was washed with some deionized water. At this point, the iodine can be used, however, I decided to do a recrystallization. 2 250 milliliter beakers were stacked. Iodine was placed in the bottom beaker and a small water pump was placed in the top beaker. A 1000 milliliter beaker had a small water pump placed in it as well and was filled with ice water. The top beaker's pump leads to the ice bath, and the ice bath pump leads back to the top beaker. This ensures a constant cold surface to form the iodine crystals. Heat was turned on, and the iodine began vaporizing and crystallizing on the bottom of the top beaker. After a while, I noticed there were what seemed to be droplets of liquid iodine condensing on the sides of the beaker. It looks like iodine can become a liquid if the temperature gets above 114 degrees Celsius. This means the heat was probably a bit too strong. I think this looks pretty cool though. After about an hour, it seemed like most of the iodine had moved to the top, so I turned off the heat and let the beaker cool. Finally, the recrystallized iodine was collected and weighed. In the end, 11.2 grams of iodine was recovered, which corresponds to a percent yield of about 59%. I think there was still a lot of iodine dissolved in solution, and a bit was lost during the transferring steps. I suspect better yields can be achieved by using more concentrated reactants like 12% hydrogen peroxide or glacial acetic acid. Other acids could theoretically be used as well.